Okay, substitution is a pretty cool method because basically you're able to take these two lines and instead of graphing them, which you would find out this one starts at 10 and goes down 1 over 1, this one would have an x-intercept of 2/5, a y-intercept of -2, and you have to graph it and find out where they cross. It's too big of a graph, so I'm going to go ahead and graph it or find out where the two lines cross without even graphing it. So what I do is I start by picking one equation and sticking it into the other equation. And here's an example of which one I'm going to use. I use the top equation, since you know what y equals -x plus 10, and I stick it into the second equation right there where the y is. So if you notice, I'm going to take out the letter y because it's no longer going to be in the equation. I'm going to take that out and stick -x plus 10 in there. So there it is in blue. You notice how it looks. This part of the equation, we stuck it right in there. So now there's no longer a y. You just go ahead and complete the rest using all the algebra you know. You distribute the negative here to that and the negative to the 10 as well. So you end up with a positive x and a -10. Combine like terms, 6x minus 10 equals 2. Add the 10 over is 12, and then divide by 6. X equals 2. Now the good news is you're halfway done. You've got your x part of the ordered pair, but you don't have the y. You have to plug this back into the original equation. If you know the x, it will tell you the y. So you plug in the 2, you get -2 plus 10, which is 8, and then bang, you got an ordered pair. These two lines cross at 2, -8. Okay, I'm going to continue on with a second problem here. Now in this problem, it's we're going to use substitution again, but it's slightly different. You notice that variable y is by itself, so you're going to take this equation and you're going to stick it right in for that equation. So on the second equation, this part will become where the y was. So it'll be 2x minus 13 equals 7x minus 3. So now you're just dealing with variables on both sides. So where are there more x's? That'd be on the right. So you subtract the 2 over. So you minus the 2x over. You add the 3 this way. You add the 3. So our equation should become 5x on the right, -10 on the left. Divide by 5, and x equals -2. All right, so we're halfway there. We got our x, -2 again. So we just need to take that and plug it back into the original, and it doesn't matter which one. You can plug it into either one. Top looks just as easy, so -2 times 2 would be -4, and -13 would make a -17. Now double check it just by plugging in the bottom. -2 times 7 would be -14. -14 and -3 makes -17 too, so you know it's correct. -2, -17. Let's check the next. Let's do another one after that. Yeah, this is a good example. See, it says watch out. So basically, I'm going to take this one more time and plug it into the y right there. So the bottom equation is 2x minus 3, all of that equals 19. So I stick in my 2x minus 1 from the first equation, and I have to distribute. So that becomes -6x. And positive 3, hopefully you noticed y with the negative. And then the rest of it's just algebra. -4x. Subtract the 3 over, it makes, what would that be, 16? And divide by -4. So you just got your x value. -4 comma something. We're going to plug that back into the original. -4 times 2 makes -8. -8 minus 1 is -9. And there's our solution. -4, -9 is where the two lines cross.